Okay, Assalamu alaikum. So this is a very small demonstration for today's lab. Today's lab is about another structure for iteration, or whenever we use the word iteration, so we mean by that repetition. So in today's lab session, you will be using another loop structure in C++, and that loop structure is called the for loop. So we'll create a very simple project, and in this project we'll demonstrate like how to use this for loop. Okay, so we already used the while loop for repeating a block of code. The for loop is another uh, structure that the C++ language provides us, and using the for loop we can repeatedly execute the execution of a block of code. Okay, so we will learn about that, like how to do that. So let us create this simple project. Let us call it the for loop demo. Okay, and in this demo basically we'll be writing a program that will find the squares and cubes of the first 100 natural sorry the first 50 natural numbers. So you can find the squares and cubes of the first 100 natural numbers or the first 50 natural numbers. That is up to you. So in order to find the squares and cubes, we'll be using the POW or power function in the CMath library. Okay, so we'll be including the CMath library, and from the CMath library we will be using the uh, power function. Okay, so how do we find the square and cube of a number? So say for example, let us declare an integer, say x, and let us initialize it to the value 1, and say we want to find the square and cube of x. Okay, so x right now it is 1. So we can use the power function. Okay, so function, again, I guess we have mentioned in one of our previous lectures that a function is a block of code that does something specific. Okay, so say for example POW, power function, it finds uh, x raised to the power y. X is the base and y is the exponent, so you give it two values, one is the base and the other is the exponent, and it finds the value of base raised to the power exponent. Okay, so it is a function to do that. So it does only that. That's why it's called a function. It does something very specific. You give it some input values and it calculates some particular output value for that. Okay, so we have the sine function, the cosine function, we have the log functions. I guess we mentioned those in one of our previous lectures. So here we'll use the power function. Okay, so how can you use the power function? So say for example we want to print out say x. We want to say x is equal to, and then we want to print out the value of x, and after that we want to print out a comma, and then we want to say x square. Okay, so let us use this notation, x hat square. So say we use this notation uh, for specifying that we are trying to print here x raised to the power 2. So how are you going to calculate the power of x? So you can use the power function POW. Okay, and give it two values, one the base, so here the base is x, and the exponent is 2 because we want to find the square. Okay, so it will find out the square of x, and after that say we want to print a comma, and then we want to say okay, we want to print now the cube of x, and that would be equal to, say, again let us call the power function, and the power function, the base, we give it the base x and the power 3 this time. Okay, So this statement, this particular statement here at line number 8, this will basically print out the value of x, its square and its cube. Okay, so here x is just one value. So let us compile this code, and then let us build and run it. Okay, so x is equal to 1, x square is equal to 1, x cube is equal to 1. That is understandable. What if x is equal to 2? If that is the case, then x is equal to 2, x square is equal to 4, and x cube is equal to 8. That is what would be printed on the uh, screen. So let us build and run it. So now we have x is equal to 2, and then we have x square is equal to 4 and x cube is equal to 8. Okay, so we want to repeat this process not just for x is equal to 2, but for 3, 4, 5, 6, 7 up until say 50. Okay, so if you want to repeat the execution of a statement or a block of statements for a certain number of times, so we have learned in our previous lectures and labs that we use repetition structures or iteration structures. So one of the repetition structure or iteration structure that we used so far, it was the while loop or the while structure. Okay, so I hope you are aware of that. Now there is another structure for iteration or repetition, and that structure is called the for loop. So say we want to repeat the execution of this particular line of uh, code. Okay, so we can use the for loop to do that. How do you write the for loop? So in the for loop, you start with the keyword for, and then you specify a pair of parentheses. Within this pair of parentheses, you specify a variable that controls the number of times that this particular for loop would be executed. Okay, we call that variable as the loop counter. The for loop is a counter control loop. That means that we have a variable. That variable starts from some initial value, and then it keeps on counting, and when that count reaches a specific final value, then that loop stops executing. Okay, so that is how counter control loops work. You use a variable, you call that variable as the loop counter. That variable has some initial value, any initial value, and you specify a condition which basically checks the final value of the variable, whether that variable has attained its final value or not, and then you specify a way to change that variable, okay, so that it reaches that final value after a finite number of steps or times. Okay, so that is what you do it. So the for loop is a purely counter control loop. Okay, so let me comment out this statement at line number 7. Why am I commenting it out? Because I will be using the variable x as the loop counter, so you can use it here. Like, we can redefine it, but let us not go into that right now. So let us assume that we are writing this for loop. So first of all, we need to specify the loop counter, the variable that will control the behavior of this loop, that will control the number of times this loop would be executed. Okay, so let us specify the loop counter and let us initialize it to some initial value. So if you remember, we wanted to print out the squares and cubes of the first 50 natural numbers. Now natural numbers, they start from 1. Okay, so that means that the loop counter should start from 1, because we are going to use the loop counter as the natural number as well. Okay, so they can be separate as well, but then you will need two variables, and you will need to modify those two variables. So here we can use the loop counter as the variable on which we work as well. Okay, so x would work as our loop counter, and we have initialized it to the value 1. Why did we initialize it to the value 1? Because we want to print out the squares and cubes of the first 50 natural numbers. So the first natural number is 1 and the 50th natural number is 50. So if you first specify the initial value for the loop counter, then you specify the condition, okay, which has to be true for this loop to be executed. Since we want to print the squares and cubes of the first natural numbers, so we want this loop to execute as long as x is less than or equal to 50. As long as this condition is true, we want this line to be executed. Okay, so we want to use x as the loop counter, and we have initialized it to the value 1. We have specified that x, if the value of x is less than or equal to 50, then you should execute this statement. Okay, then we should execute this statement. We have specified this condition. So for as long as this condition is true, this statement would be executed. Okay, and then we need to specify a way to modify the loop counter so that it reaches this final value in a finite number of steps. Okay, if x is not modified, if x remains 1, so this loop would be an infinite loop. Or if we modify x in a way that it never reaches the value 50. For example, we can do something like this. We can say minus minus x. We can decrement x. So x initially is 1, then it would become 0, then it would become minus 1, minus 2, minus 3, minus 4, minus 5. So x is decrementing, x is moving away from 50, it is not moving towards 50. So this loop would become sort of an infinite loop. It would not be an infinite loop. Why? There is a good reason for that. Let us not go into those reasons right now. That has to do something with the way integers are represented in computers. But this loop would not execute 50 times as we intended. It would execute more than, I guess, 2 billion times. Okay, so that is how many times this loop would be executed. So it is important that we modify the loop counter in a way so that this loop executes a finite number of times, as many times as we intend it to execute. So we intend this loop to execute for the value of x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4, up until x is equal to 50. So that means we should, if we start from x is equal to 1 and we want to get to x is equal to 50, so we should increment x. So after every iteration of this loop, every repetition of this loop, the variable x would be incremented. Okay, so when we run this code, like we can compile this code and we can build and run it, and inshallah it would run fine. So let us give it a run. Let us run it. When this code starts running, what will happen is this loop counter at the very first time your computer enters this for loop, this particular statement in which we initialize the loop counter, it would be executed only once. So the variable x would be initialized to the value 1. Okay, this statement would be executed only once, the very first time we enter the for loop. Okay, so x would be initialized to 1. Now 1 is less than or equal to 50, so this condition is true, which means that the body of the for loop, which is this particular instruction, now this is just one statement, sorry, which is this particular statement, this is just one statement. That's why we have not created a block. But as I mentioned, like it is always a good idea to create a block of code. Now let me execute it once without creating that block, so you'll see like it executes perfectly fine, and then we'll create the block. Okay, so This statement is executed only once. The very first time you enter the for loop, so x would be initialized to 1. Then this condition is checked. Is x less than or equal to 50? So x is 1, which is less than or equal to 50. So this condition is true. That means we can execute this statement. So this statement would be executed for x is equal to 1, and the values of x and the power of x raised to power 2 and x raised to power 3, those would be printed, and then we would get back to this particular line. Okay, in this particular line, before we get here, x would be incremented, x would become 2, and then this condition would be tested. Is 2 less than or equal to 50? The answer would be yes. So this statement would be executed once again. After it is executed, this statement would be executed. X would be incremented once again. It would become 3. Is 3 less than or equal to 50? Yes, it is. So this statement would be executed once again. This statement, this one, where we initialize the loop counter x to the value 1, this is executed only once, the very first time you enter the for loop. After that, it is never executed. Okay. So after that, it's just these two statements. Once the loop is the body of the loop is executed, then the loop counter is modified according to this instruction, whatever you have written here. And once the loop counter has been modified, then this condition is tested, whether this condition is true or not for the new value of the loop counter. If it is true, then the body of the for loop is executed. So let us build and run this code, and we'll see it works fine. We have the squares and cubes of x equal to 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, up until 50. So we have these values up until 50. Okay, so the code works fine. This is the simple for loop where we repeat only a single statement. You can create a block of statements as well. How do you create a block in C++? You use the curly braces. Okay, so here you can see. Okay, so this is like a block, or still like we have this one statement that we want to execute over and over again, but nevertheless this is how you create a block. So this is basically the simple for loop. Okay, so the for loop is slightly different than the while loop. In the while loop you have the keyword while, and then you specify the condition. It's just the condition here. Okay, there is no initialization and there is no modification of the loop counter in the while loop. Whereas in the for loop you do everything that you need to do in order to set up a counter control loop. So in order to set up a counter control loop, you need to specify the loop counter and initialize it to an appropriate value. You need to specify a condition that has to be true for the loop to be executed, and then you modify the loop counter so that after a finite number of execution of the loop, you reach the terminal value of the loop counter, and the condition that you have set up for the loop, that condition becomes false. So once that condition becomes false, then the loop stops executing. So we are always looking for ways of creating finite loops. Okay, loops that execute a finite number of times. We are not looking for creating loops that execute infinite number of times. Okay, so this is basically just a simple demonstration of the for loop. This will help you in today's lab session. In today's lab session, you're basically going to rewrite all the programs that you wrote in your previous lab, but this time you will be using the for loop instead of the while loop. Okay, so this will give you a practice of the for loop. Okay, so that's it for this demo. Thank you.